Hello. Now let me illustrate my project, Comprehensive Local LLM and Chatbot Development Project. All my code and the experiment result could be seen on the GitHub link here. First is local LLM setup and interaction. Setup Llama 3. I set up Llama 3. I simply use the Ollama command line. Wait a second. Hello, who are you? So you can see I can talk with Llama 3 on my local device. Bye. Next, chose and set up a second LLM. For second LLM, I chose Google's Gemma 2. Just simply exactly similar command line. Now you can see this model's name is Gemma. The text it generates is a little bit shorter than Llama 3. So I can type Ollama this to solve all the models and their size on my computer. So next part is command line interaction using Qro. In this part, I developed a two Python scripts, that is querySender.py and main.py. And yeah, let me show you my VS Code. First, the query sender. Basically, the query sender sends a query to the model and returns a response along with the timing, token, statistics. The parameter to this method is model name, the name of model for query. The prompt is the initial query done to the model. Temperature is sampling temperature, which controls randomness, and max token, the max number of tokens the model can generate. And conversation is an optional parameter. It is a list of previous exchange for multi-turn conversation. So, and the return of this method is a packed result, including total tokens, timings, and models generated response. So basically, I call the API for querying the model, and then takes the response and returns this information. And in the main script, I test two models, Llama 3 and Gemma 2. And for each model, I run 4 experiments. They are simple query, multi-turn, conversation, parameter, experiment, and specific task. So in simple query, I simply run a simple query and writes the result to a file. In multi-turn conversation, I run the multi-turn conversation and writes both response to both the first prompt and the response to the first prompt and second prompt to a single file. First, I initialize the conversation with system message and send the first prompt in this experiment is who are you, and send to the model and gain the response and append the first interaction to the conversation history, and then send the second prompt and gain the response, and then combine both the result to the file writing. So, for example, you can see the result. This is the first response, and this is second response. Next experiment is parameter experiment. I run the model with different parameters. There are temperature and the max token. I tried these different combinations. And the fourth experiment is run a specific task and write the result to a file. And the detailed result could be seen in the text result folder in GitHub on GitHub. For example, I just open one. It shows the total tokens, the model generated, total time used, time to generate first token, and the average token latency, and the final generated task, the text. And the comparative analysis, I will not read it. And if you are interested in the analysis, just read the report. Second part is domain-specific chatbot development. And domain selection, I select domain for AI chatbot is computer systems, with a focus on topics related to system programming, OS, and distributed system, and some other low-level programming concepts. So the target user base is basically undergraduate computer science students who were struggling with the final exam about computer science. And here are some use cases. For example, final exam preparation, problem solving, assistance, clarification of concepts, and study planning. I deploy my application using Docker, using Olama's OpenWeb UI and deploy it on Docker. So first, let me open Docker, and then I can it's on my local. Yeah, you can see the user interface is very similar to ChatGPT's. I can select model here. I can start a new chat, and for example, I choose Llama 3 and say hello. Yeah, how are you? It's a very looks like a ChatGPT developed on your local host with beautiful UI and an abstract backend. So yeah, the face looks like this. And for chatbot implementation, I use base model Llama 3 and retrieval argument generation technology. So basically, I upload the famous textbook Computer Science: A Program's Perspective to the for the document to the document retrieval systems and integration with RAG. So to test, so first let me try some crisis model. Um, you can see the conversation history with with Llama 3 plus SAPP. I can ask some question about computer system, and it seems so the assistant of the model give me a robust, a very high quality response. And how to solve, then I test and evaluate the domain-specific model I developed. So basically, I chose 10 single choice question from the CMU final exam, and test the Ray Llama 3 model and the Llama 3 model plus TSAPP RAG. And here's the conversation. I asked the model question, and it gave me the answer. And the problems and the answers are here. You can also see them on GitHub. Problems and answers. Here is a testing history of Ray Llama 3 model, and here is the testing history of Llama 3 plus CSAPP book. And as you can see in our domain-specific model, it first search the CSAPP book and find the 3 citations. Let's see, for each question, find 3 citations, and based on this information, and it gives the answer to our question. So let us look the result. So on Ray Llama 3, the Ray model correctly answered 4 out of 10 questions, achieved an accuracy of 40%. And on the Llama 3 plus the SAPP model, so this augmented model correctly answered 8 out of 10 questions. So they achieve an accuracy of 8% and 80%. So the huge improvement shows the usage of the effectiveness of the RAG methodology. Okay, that's all. Thank you for watching.